Okay. Wchodzimy.
Okay guys, so I think we can start our live webinar tonight. Please let me know that you can hear us and see us well in the comments section, please. On your right there should be a comment section that you can write at, or maybe let us know on our Facebook that everything is fine, so that we can start and announce our tonight's speaker, or speakers actually, because there is two of them. So please let us know that you can hear us and you can see us, so that we can start. Okay, Wojciech says, yep, we can. I'm very glad to see that. Kamil is with us. Hi, yeah, you see us. Another Kamil, and Oleg. Hi guys, really nice to see you tonight. We are very happy that you joined us. More than 170 people joined us tonight. I will let you know about that in a while. Okay guys, so 30 seconds and we can start our we are live. I'm really happy to see you guys tonight. As you can see, this is the first game developer meetup that we are doing online because of the COVID situation, but we are very happy that you guys are here with us. Joining us tonight is Oleg Gavriliuk and Sam Frisch. They will share some very great knowledge with you tonight. You can also ask them questions, but I will let you know about that in a while. Okay, so my name is Dorota and I'm really happy to be here with you tonight. I will announce our speakers, and I will also be the one to read your questions in the Q&A section of tonight's event. But I'm also welcoming you from the guy that is sitting right next to me, but has decided not to show his face tonight, but he's here with us. And by this man, I mean Paweł Niewęgłowski, who is our community leader, and he makes it all possible for us to meet here. Should you have any questions or any ideas that you would like to share, please let him know about the ideas that you want to be realized in our meetings. hello@gamedevmeetup.pl is the email address that you should write to Paweł Niewęgłowski. Okay, now we are aware that many of you would like to meet in person, because it's for some people it's easier to ask questions or share their thoughts when we can see each other and hear each other live. But obviously during this time it is difficult for us to meet, but we are very happy that you joined us online. Due to the COVID situation right now, we are trying to meet as many people as we can online. So tonight is our first game developer meetup online, and here on the screen you can see the goals that we have for us and for you. We want to integrate the game dev industry. We also want to create an exchange platform for knowledge and experience. We also want to host events that will create a even bigger community, and we also want to assist you in your career development. So you can also find us on our meetup, meetup.com. Please be sure to check out Game Developer Meetup Poland out there, and also our socials, Facebook. I heard that there was a huge problem with joining Facebook today, but we hope that those issues will be resolved as soon as it's possible, and once everything works, please be sure to visit us on Facebook also. And now a few words about our main sponsor, SoftServe, which is a great friend of ours, and we are very lucky to have them as our main sponsor. SoftServe is a global technology company specializing in consultancy services and software development. Currently with 50 offices in 11 countries, the company employs more than 8,000 people. SoftServe has been present in Poland since 2014, where it employs over 400 people in 5 locations, which are Wrocław, Gliwice, Białystok, Warsaw, and Poznań. SoftServe has recently opened a new R&D center in Poland. Their team applies expertise in machine learning, engineering, augmented and virtual reality technologies, and advanced scientific research. And to find out more, please visit their website, which is joinsoftserve.com/rd. For your future, that's what SoftServe is for. Now you can see the numbers. Not only I'm telling you about it, but you can see, as I said, in Poland, they've been present for more than 6 years now, and 400 employees are happy to work for SoftServe. If you would like to join their global offices, there are 11 countries to choose from. Please be sure to visit SoftServe. Right now we are showing you the QR code that you can scan to visit their site, but also, once again, joinsoftserve.com/rd. And here you can see our partners and our media partners that support us so that we can meet you guys online and let you know about our projects. Okay, so as I said, we are sure that there should be 171 people. Maybe there's even more. Let us know that you're here and you're ready to watch our specialists share their knowledge with you. And also, if I may say so, our warm greetings to Daria from SoftServe, who made this collaboration possible. Hi Daria, thank you so much for all your work that you are doing. Okay, speaking tonight, two great specialists. There aren't many like this in the world. We know that there are very few. So we are really happy that Oleg Gavrilyuk is joining us tonight with his subject. You can see it on your screen: analysis of sparse seismic data in VR using the Unity 3D engine. Oleg, a research lead with 10 plus years of experience in software development. Currently, he's working on projects with augmented and virtual realities in diverse environments, from handheld devices to web frameworks. Unity is his preferred instrument for fast prototyping and idea validation. As a researcher, his activities are focused on novel areas of the human-computer interaction in extended realities and interaction with machine learning systems. Also with us tonight is Sam Frisch, who prepared a very special subject for you: Molecular MR Multiplayer, a cross-platform collaborative interactive game for scientists. Sam Frisch is an R&D lead with 10 plus years of experience in game development, virtual, augmented, mixed reality, and computer vision research, including service R&D projects for customers like Samsung. He leads the research and development efforts in human-computer interaction and computer vision. We are very happy to see you both tonight. Now about the questions. Please be sure to leave your questions if you have any. We understand that this is a very narrow, specialized subject tonight, so if you have any questions, if you want to learn more about what our speakers say, or if you want them to expand some of their thoughts even further, please be sure to ask your questions. You can do it in the comments down below or on our Facebook. There should be a post that you can also leave your comments under it. Okay. So after Oleg and Sam are done with their presentations, I will be reading your questions. I hope to be able to read them all if we have time. Okay, and now for our first speaker, the first one to tell you about about his subject is Oleg Gavrilyuk, analysis of sparse seismic data in VR using the Unity 3 engine. Oleg, can you hear us? Can you see us? Because we see you and I think we can hear you pretty well.
Hello.
Hello.
Have a nice evening. Yeah, my name is Oleg Gavrilyuk, and I can hear myself. Maybe, yeah.
We can hear you. I think
Test,
we can
test. Yeah, excellent. So no echo right now. Okay, my name is Oleg Gavrilyuk. I'm research lead at SoftServe. Today I will be telling about a bit of scientific topic, but it is implemented in the 3D engine Unity. So I suppose it would be quite interesting because while it is scientific, there is a lot of different details that can be used in game development, I assume. So let's start from usual slides. It's about me. Actually, I had part of this slide, but I would like also to add that we like Unity in our research and development because it's a fast prototyping tool. It actually lets us verify our scientific theories quite fast, and with a bit of integration with different assets, frameworks, and other like this, it's quite convenient. Also, I was working
Oleg,
with different. Yep.
can you hear us? I'm very sorry to interrupt you,
Yeah.
but we are
Yeah.
receiving some comments that not all of the people can see your presentation. So is your screen sharing
Sorry.
working? Is it
I
working?
will check it.
No,
Give me a
Uh-huh.
second.
Yeah. You know the share screen,
Okay.
right? Oh, okay, here it is. Okay,
Yeah.
I'm very sorry. I
Excellent.
won't interrupt you
No,
again. Thank you.
no, feel free. Um, yeah. I was working with different top-tier clients like IBM, Google, and something like that. And let's get back to our topic and to the seismic analysis tool. First, I would start with geosciences and seismic data. Geoscience is science about the Earth, obviously, and there is a pretty long list of usages for this science. It has a quite extended usage for different Earth projects, glaciology, hydropower, geophysics, renewable energy, and so for nuclear energy, and even paleontology. Everybody likes dinosaurs, and I like dinosaurs, and we can dig them up with using the geoscience. But today we will be talking about a small part of the geophysics, about the seismic data. The seismic data on this picture is actually the data of the Earth beyond sea level. Uh, it is below the sea bottom on the it's a lower right corner. And let's talk about seismic data for the beginning, because without a bit of understanding what we are doing there, it would be hard to explain what the technical issues we had when implementing this project. So what is the seismic data? It's a very interesting thing. It is used to build the models of the structure behind the Earth level. So how it is acquired? There is a ship that drags a very big set of sensors. It is a set of sensor is something like 8 kilometers long usually, and there are 700 up to 1,000 of sound sensors. And the ship has a couple of sound emitters, and these sound emitters actually emit sounds that go through the sea down to the bottom, and every frequency is refracted by by the type of structure that is below the sea level. And when the microphones they're receiving the refracted sound, and then by the changes of frequency, we can understand actually what is the structure that's below the Earth. The same technology is used for the Earth manipulation, but sometimes it is not used like on the ship. On the Earth, sometimes they just blow up things. They dig the hole, they put the explosives, blow up, and then by refraction of the sound of the explosion, they can build else of the map. But in the sea, it's much easier to use sound microphones than just to dig the bombs on the bottom of the sea. So when the ship is going on the sea top, and it produces the levels signals. So under the surface of the sea, it gets the picture. It's number 2 on the slides. So it is the signals that is actually produced. And obviously we need a 3D data, only to data of like we call it slice to data of the signal is not so informational. We need a lot of such slices to get a whole picture of the structures that's on the bottom of the sea, to understand it's called subsurfaces, and for us to build models of surfaces. Um, what what's the model of surfaces behind it, the bottom of the sea actually? Yeah? It is a landscape of the Earth that existed in previous millions of the years. Particles of dust and earth are slowly coming down on this bottom as well on the Earth's surface all around us. So usually Earth level is sinking very slowly and just go beyond the ground. And if you would visit old cities, you would notice that the first floors of the houses, they are very low to the level of the earth. Sometimes they go in even below the earth level. That's because everything is going down, like in water, but on the earth surface, obviously, it is very slow. So under the sea bottom and on the earth level too, there is, if you go down, you will see a landscape that existed millions of years ago. It's a bit compressed because of the pressure, but still we can, by using this sensor data, we can actually look what was the landscape of some part 100 million years ago, 200 million years ago. It's very interesting. It's like a time machine. We call this time machine when you can just go to the surface that was 300 million years ago and look around and to see something like rivers, mountains, everything like this. So back to the seismic data. When we get the data, we actually analyze it, and we form the interest regions for us. And if its usage is for and oil and gas industry, and we can find some oils, and we just put an oil rig on the top. Um, yeah, it's commercial project anyway, so there must be some commercial usage finally. Okay, so what is the data we are working on in the seismic analysis tool? This is the slide that actually shows the data, it's finished data. So everything is drawn here. But obviously we work a lot with raw data, not beautifully colorized and not beautifully analyzed like here. But this actually shows the final result of the analysis. On the left slide, you can see what I was talking about. That's different, I suppose this is an oil. The green is oil and the red is gas, is natural gas, and the yellow is sand. So this picture is analyzed and is fragmented, and we can see, and even there is two oil rigs on the top. But on the right, you can see the picture from the above. Like on the left, it's analyzed picture. On the right, how it looks above. And if you will see, you can see that actually it is a river channels. And it is very important moment that if we like say pretty simple, we can say that uh, oil and gas are gathered around the channel system. I would not go in depths of physical things behind physical explanations behind this, but like pretty simply saying, we are looking for the channel system. This channel system is easy to see because it is a live view, and all the geoscientists are trained on the real world examples. Obviously, what they see is this analysis, and like what they see is actually this very raw data, And you can see on the fourth picture, it is a surface that is extracted on the some seismic data. It's you can see it's a mountain and even some valleys. They work with very simple with raw data, but they need to understand and to find something like this, like a real world uh, system. And what the idea behind this project? Obviously, if we have a 3D engine and a bit of computational power, what can we do? We can try and we can achieve the visualization of raw seismic data. So we can get a surface that is hidden inside the data and colorize it, texturize it, put water channels on it, and to see it like in first person worldview. And thus greatly helping scientists to understand what they're looking for, and also to analyze these signals not on the pure screen, but on the top of a real landscape. That's also helping a lot because it's much easier to notice something when you're looking in visualized thing, not just in raw and seismic data. What are the main technical challenges here? I would go first to the technical challenges, just to understand what was behind it. Obviously, it's the size of data. It is more than 1 billion of dots, data points. Usually 1 billion of data points is like on the lower side, and we can go as big as to 10 billion data points, and like this data set is also very heavy. It is and 4.5 up to 10 gigabytes for each data set. There is a free slices that we need to show. I will talk about slices maybe a bit earlier. And also, let's not forget that the actual area size is very, very, very big. This cube of data represents up to 40 kilometers, square kilometers, and the channel systems are enormous. Mm, no geolocation data here in our project, but still it is very, very big channel systems, and it's not that easy to analyze it. Also, we need to produce water, and obviously, as we are working with VR, there are limitations for VR, and we also will talk about it later. Okay, let's show a small video. What was like it's promo or something like that of our no sound obviously, but you can see a landscape. It's something like this one is 100 million years ago with a channel system. Yeah, we have a very actually these waterfalls are very big, 100s of meters. There's our menus, and here we see analysis overlays on the surface. And this is also analysis of overlays with raw data. So this is an actually data behind the whole cube, and it's just a fancy way of traveling around and a fancy way of going through this the surface actually. Okay, so let's talk about implementation. No examples of code, but just an overall approach. Okay, the surface. As you can see in videos, there were two parts First is the building of the surface, and the second part is the analysis. The surface building is a bit simple because what's interesting here, if, for example, we have 40 square kilometers of the river systems, of the data, and we must find good river systems here there. It's interesting that there was not more, like in the data we work in, usually 3 or 4 river systems that were interesting for us in the whole cube. So what I'm talking about, just imagine for the last 1 billion years on the 40 square kilometers, there was only 3 times in 1 billion years when a very large channel system, river system, existed in that place. So the river systems that big are very rare in billions years. And from some point of view, maybe it's a bit sad because maybe there was some sense or deserts, I don't know, but it is simpler for us to analyze because we don't need to produce a lot of surfaces. We can just prepare data for usually up to 10 such surfaces, as you can see on the picture. And there is no secret here. We get a height map from this cube. And if we get heat map, how it is easy to build the terrain. We just go with Unity terrain system and we just use a heat map to build the terrain, and we just use a set of rules to texturize the terrain, to apply all the textures, and depending on what the slopes, what the range, what the heights, and everything like that. We were using the ready asset map magic. It was most convenient and most fast. And using this approach, we are like we can build one surface from the data, from preliminary prepared data for like 30 seconds. It's very fast. For a seismic data analysis tool, it's very fast. Okay, in this current project, we bake it into the scene, and it was like loading of the level. Some tools for shaders, some tools for water, but not that much technical difficulties here. But we can go to analysis tool, and that's where our, sorry, and that's where our story gets a bit more interesting, because analysis tool needs to process data. And don't forget, we have 1 billion of points, 1 billion plus of points. And we need to process it. And just for fun, unfortunately, I hope someone will write in the chat. It's fast blitz quiz. How many do you think objects C# can hold in simple list? Like if you just get a list object in C# and you just put integers there in the list, how many integers you can put in the list object until it is fall out of the out of memory error. If somebody would write to the chat, I'm not sure I'm able to read it, but I hope our assistant would read it. Answers? No, I give you just a couple of seconds to write the answers. Okay, so the right answers is around 530 millions of integers. So if we work with billions of points of data, we are not able to store it in a common way. And the problem is processing this storage. The simple for loop for such amount of data is very heavy. We can get 7 seconds for 500 millions of points data to process, to just go through. And if we apply some operation on it, the numbers go up twice, thrice, quite fast. We were not able to process the data in real time, but we still need to show the slices and to work with it. Mm, Another another moment is the memory for storage of the data. Uh, it will be very big too, and the problem of loading of 4 gigabytes of data in the memory is pretty hard. We were looking at the computational shaders, but actually we used another approach. If you would see on the picture, uh, we can see visualization and it's a texture, and it's like a picture, usual picture. And if we will take a look on the raw data, we can also say that it's a set of pictures here. So as a technical approach, we just pre-bake it everything in the textures, and it immediately gave us a very good results. And because not getting 1 billion of data points, but 3,000 of textures is very different. Obviously, working with 3,000 of textures is another story. But we're capable of working with it, not with 1 billion of data points. And immediately we get a processing of this tool, because scientists want not only just to look on this data, like how it is visualized on the surface, they want also to work with it. They want also to manipulate the data in somewhere to increase some margins or reduce the margins, to select some appropriate range. And if we work with raw, that it's not possible, because like 10 seconds for only for one loop, it's absolutely no. But if we work with textures here, it is possible, because every just custom surface shader can perform mathematical operations on the fly on GPU ultra fast. It's easy to implement and easy to keep, and we can use custom geometric shaders also for surfaces. Mm, So it was a very interesting solution for us, and it gave us a lot of flexibility here. And without this approach of data as textures as a pictures, I don't think we were able to implement the project at all. But there are also some minor technical problems also, what were also the water. If you can see, we have a water flow, and obviously building water as a set of particles, this fluid generation and fluid calculations. Fluid calculations are very heavy, and for an area of 40 square kilometers, I don't think that actually any solution that is able to calculate the 40 square kilometers river flow exists. Maybe some supercomputers. And real-time water again was not the issue here. But what's good with water that we can calculate water not basing on the particles if we have a landscape, but we can analyze the water flow just depending on the surface of the channels. If we are given some starting points, we can just calculate the flow without using the particles. Just by analyzing the slopes and the bottom of the channels, and then we are able to build the water using any usual approach you may imagine, just planes and the water shaders and something like this. Um, like that's a good approach if we have very complex surface, very complex shaders. It worked like a charm, and you can see that we were able to even apply to some effects using standard approaches, and even water asset can be used here. The last but not least was virtual reality problem, because we need to put it inside the virtual reality helmet, and 40 kilometers to travel around in VR helmet is not possible even when if you use teleporting, because 40 kilometers is too much, and usually the surface is quite plain. So in VR, we had to implement some types of squeezing of the surface, just to help scientists not to get lost inside some kind of channel. But finally, if we're able to squeeze automatically, we are able to help them get through the channels and jump on some maybe waterfalls and everything like this. So that's thank you a lot. I hope like my talk was not too technically oriented, and you had some joys in listening to seismic details about. And yeah, thank you a lot. I'm ready to give up the word for Sam Frisch. Guys. Hello. Yeah.
Hello, hello. Can you hear me?
Yeah, absolutely.
Okay.
Yeah, a couple of minutes earlier. I hope it's okay.
Yes, of course. Yes, of course. Thank you very much. We tried to connect even a bit earlier, but we are happy to be here. Thank you so much, Oleg, for your presentation, all your knowledge. Now, is Sam with us? Oleg, I'm hoping you will join us during the Q&A section, okay? Because we have
Yeah,
some questions.
absolutely.
And if I may add once again, guys, if you have any questions to Oleg or to Sam, please be sure to leave them. I will try to gather them all and show our speakers. Okay, Oleg, thank you very much. And Sam, can you hear us and can you see us?
Yes, I can hear you and I can see you.
Great, we can see your screen also. So, guys, I'm leaving you with Sam. He's one of a very few people in the world who knows this and who can share his knowledge. So, please enjoy.
Thank you, guys. I'm a vivid game developer. I'm making games since I was 20 years old, so it's kind of 30 plus years now. And uh, several years ago, I was caught by guys from R&D. I thought there is nothing more interesting than games, and then I came to this uh, hard, challenging problems, and then we found the way that we can make games that named serious games, games that are proposed for purpose other than entertainment. So firstly, we created the game that was to teach AI. It was 4 years ago, and then we came across lots of topics. And last half a year and a half, and maybe a bit more, we were working on the project that connected not with earth science but with life science, and we performed a lot of manipulation with chemical data. So we made the fusion of mixed reality, uh, um, life science, and game. So the team who worked on this project are Max is a scientist. He has deep background in physics, and lastly, he is working on life science projects. They worked with drug discovery and came into more difficult parts of chemistry. They generated large molecules with AI. And actually, first we met with Max. He provided me 11 pages of his paper, and I tried to understand how it works. And honestly, I understood it 10% or so. Then we tried to make this large, heavily science-packed stuff interesting, sellable, and then it came to gaming direction. And Gleb, who is trainee at our team, helped to implement that. And actually, the part we are presenting is a poster made for ACM, Association of Computer Machinery, for scientific conference VRST, Virtual Reality Symposium of Virtual Reality and Software Symposium. It was held a month ago in Toronto, also virtual. And there we were presenting this game concept for scientists. I also took part in this project. I am lead at R&D, and I'm leading interactive direction here or there. And we are working with research here in interactive team. Our interactive team works with interactive expo experience with digital signage. That's for everything that can be shown on surfaces, from signs on the road to larger screen in cinema or at drugstore. We heavily dig in on mixed reality. I'm a believer of this technology, and I see that as one of the most challenging tasks in interactive direction. We do supporting stuff for 3D data synthesis when you trying to teach AI something hard. Data generated in virtual worlds, so virtual worlds themselves are very helpful. When you came to something dangerous, something impossible, or something too complicated, you can generate it within Unity or Unreal Engine and make advantage of that. And as I mentioned, and that's why we are here, we are focusing on serious games, and one of them I'm presenting now. So we demonstrate a concept of emergent gaming like remote collaboration experience for the researchers, helping them to explore and design chemical compounds. Actually, in interactive, in gaming way, and mostly for preview or for marketing purposes. But if you can imagine, and let's imagine that several scientists have their brilliant mind with ideas, and they can provide and show these ideas in real world or mixed world or world overlay, here or there, remote or local. It's a lot of possibilities, and it's closer to game once again. The game, or the app, let us say that it's a game, runs on the edge devices, so it can be a phone and can be or a headset like Magic Leap or HoloLens, on maybe Unreal, but we didn't try it yet. It also runs on a standard laptop, and we can operate with smaller moleculars on these devices. As I mentioned, it supports mixed session between local and distant users. It can be only local users in one room, and then moleculars are placed over surface in this room. It can be people in several distant rooms, and several in local, several in distant. So molecular multiplayer was like human-computer interaction and human-centered computing, or and mixed and augmented reality. And from applied side, it's bioinformatics, and it's actually booming now. So we are trying to support it, and we contribute with such demos and publications to conferences like IEEE or ACM's events, and naturally not only scientific but more promotional ones. We showed that those demos all over the world at conferences like Google Next or at AWV, Augmented World Expo, these are similar ones. So collaborative mixed reality is definitely a step over virtual reality solution for human machine and human to human interaction. It might be doubtful, it might be like for believers like me, and then might be not yet proved, but mixed reality is a next step paradigm. And when you see something in the virtual reality, it's several degrees or several thousand times, 100 times easier to show, because you don't have to perform a lot of tasks on synchronization with real world, on the recognition of the real world. And actually, these mixed reality devices are not see-through, but actually with transparent optics are state of the art, I guess. It's some kind of masterpiece. Yeah, I guess if Oculus 5 years ago came with such a decay like Microsoft or Magic Leap do, they going to be a state of virtual reality now much more faster. We reviewed a lot of solutions that were previously on market or emerging like now. Mostly they are for virtual reality, for flat screens, and larger companies like Novartis or Pfizer digging on this problem a lot of time with lots of resources. From the other side, collaborative tools like Sansar or Spatial or Facebook Horizon or dozens of others are also present on the market for ages. But the mix of mixed reality and remote collaboration in chemistry is a unique tool, and this part making this scientific or publishable, we have some kind of novelty in this solution that we do for the first time. Let's get down from this inspiring or abstract things to more practical. Everything works on technology, everything works on hardware. And this project actually is one of several under the umbrella of our cloud research program inside our R&D team. And not surprising, giants of the market are working on similar technologies. So Google, Microsoft, Snap, Facebook, smaller companies like 6DAI or 8 Wall or Niantic that makes Pokemon Go, but makes these background technologies. They have some public IPs, they have some publicly published papers, and they trying to do the digital copy of the wall, some kind of Google Maps on steroids, more precise, more indoor, more interactive. That's why we tried to take advantages they provide. We analyzed solution from Google named Arcor Anchors. I'm sure a lot of you have experience with that. It works perfectly on Android devices, but there is no implementation of such anchors for Magic Leap. Microsoft Azure Spatial Anchors works perfectly on Android, iOS, on HoloLens, and naturally not on Magic Leap. Magic Leap native transmission works on Magic Leap, works with Android or iOS tablets or phones, but doesn't work on HoloLens. That's why we have to find some kind of personal solutions. We taken have taken reference architecture from Microsoft that uses Photon server that and run that with Magic Leap and with handheld devices. It was tons of challenges there because this is a touch that is under heavy development. So SDKs and OS for Magic Leap are evolving, and let's say we are trying to create something on the fly, and this paradigm of placing molecules in real world or other object in real world is has lots of limitations. So firstly, we achieved problems with drift, with not synchronizing, with losing objects, with not smooth placing, with mixing floors, because we can't tell is a second floor or third floor. But we overcome that, and actually now we can pretty stable work these smaller moleculars. Cross platform placement also heavily integrated with cameras. So when you're using the phone with Arcor, let's say, and when you're using a headset with stereo cameras with highlights, we have absolutely different placement, we have absolutely different frames, and so on and so forth. So we try to match walls or wall frames via computer vision using standard checkers, like everybody knows. We matched worlds with just placing controllers in place, and actually with controllers is faster, with computer vision is more precise, but actually it's everything about trade-offs, and network synchronization is painful here, because when you have four or 400 atoms in molecule, it's nothing special. But when we've got something real, like in this organic molecule, it can be 400 of atoms. Sending this over the network to make it smooth, it's a kind of problem. So we used classic gaming techniques of interpolation there. Also, we overcome questions with joining and leaving the rooms, changing hosts. And actually, it's pretty trivial task with photon core functionality, but it's worth to be mentioned. And much more interesting here, because it's just the emerging part. We have first-person view on headset, and we have third-person view on the phone or tablet or PC. And for interaction with other users, we have to have some kind of embodiment, and even these simple avatars are absolutely different to operate in first-person space and third-person space. But we overcome that, and maybe as a bonus that can be interesting for game developers, we tried to put 4,000 or 5,000 of molecules onto edge device named headset that can run up to 300 polygons, or limited draw calls, or limited of more depth, more slower it runs or overheats. So we tried to do like it was 20 or maybe 30 years ago on PCs. We made sprites, and then it works with thousands of molecules easily. That's like a dirty hack, but still works in up-to-date world. We can see screenshots from our app game on PC, when we can measure distances between atoms in angstroms. We can measure angles between three atoms. We can measure torsions between four atoms, and actually we can highlight, move, swipes, and we experimented with that months long, because actually we tried to build interactions before it came to SDKs. So our guys were convincing me that better to use ray pointer and better to interact with objects with ray pointer like it was on Vive or on Oculus. I was a believer in real spatial computing. Talked them that we should better use controller as a tool, that we can with better interact with molecules in place, like a professional in Forge with hammer and something like that. And actually they were right, because now in Magic Leap we've got the race as well. We experimented with gesture and eye gaze input there, and actually here controller in my mind wins. And that's why that's the part of gaming experience that we provided at the expos or at test runs to the people. And this is a part of scientific research, maybe lab research experience, when we try and is this kind of interaction better than the other kind of interaction, why it is better, we can merge it, and we can touch some kind of psychology there. And lastly, we can see CamRip from on the left and CamStream on the right. It's also tricky working with streaming on Magic Leap or other mixed reality devices. So you'd better do this tethered because on Wi-Fi we've got not HD picture, but still gesture input here with streaming uh, may fall down below acceptable performance. Uh, Also, mirroring like on the second screen is kind of tricky because you see one thing and the guy in the other headset can literally step over you and be you can be crossed in physical space. So I created a single user prototype, a series of single user prototypes. We experimented with different interaction scenarios. We transformed up from a tool for selling to tool for help and marketing, and then for gaming-like experience that helping people to bring some more ideas and gamify their research process. We find novelty and uniqueness within mixed reality, chemistry, and spatial computing. And that's it for now. Thank you. Welcome to interact with me via mail or Twitter. Questions, please, I guess.
Stem, are we here? Okay. Okay.
Thank you.
Thank you so much. Okay, remove. Great. Okay, guys, so now we can start our Q&A session. We uploaded all the questions to our bar here. Some of them we had to translate, but I hope we will translate everything well. Okay, so the first question Pavel is showing right now. Okay, how's the performance of certain scenes created with Unity 3D and browsers? Which one do you think is the best? Because our viewer heard that the best performance you can see on Firefox. Okay.
Yeah, actually, if we are talking about the browsers and Unity 3D, I don't think it's correct to use Unity 3D for browsing because it's pretty limited. The performance is good because they use WebAssembly approach. They wrap everything into the native browser's code. So the performance is good, but there are a lot of technical limitations with browsers, and development for browsers is not that easy. Unity 3D is good for mobile platforms and for fast prototyping for desktops. For browsers, I assume there are special frameworks, and if you want to go strictly to browsers, you should go with these 3D engines. But obviously, if you want to go cross-platform, you can do it, but there would be a lot of custom things for browsers. Our experience with Unity 3D and browsers was not that excellent, and sometimes we met a lot of strange behaviors. I would not recommend it.
Okay, about strange behaviors and challenges, there will also be a question in a moment. So thank you very much. And now, will Pavel please show us the second question? This is the one. Okay, so what is your opinion about the European game dev? The community, the business itself. How do you see the European game dev? Are we strong out here in Europe, or do we have to learn even more to be able to be as good probably as Asians or in the United States people?
Sam?
Do you hear me?
Yeah,
Yes.
now we
Yes.
can hear you.
Okay. I believe that European community is totally strong, and especially Polish one. I'm fond of works like People Can Fly or CD Projekt. Uh, the Cyberpunk 2077 is out today, and it's a masterpiece. I'm looking forward to play that. So I know a lot of people from around Europe, like in Sweden, Ukraine, Malta, you name it. So I would say GameDev Europe is strong, and let's make it stronger.
My opinion on this is that European game dev, from our point of view, is a bit seems like more indie one with a lot of smaller studios, while Western like states and that they try to be a bigger one, so they are good incorporated and grow in big companies. So that's the difference, more corporation approach in Western parts of the United States and a bit indie, smaller approach in European, especially in Eastern European.
Great. I am really glad that you guys mentioned the cyberpunk release today because it is one of the questions. Today is an important day for the whole game community. Cyberpunk 2077 premiere. Any first thoughts on CD Projekt and the game itself? It's been a long wait, right?
It's been a long wait, and I guess it's worth it. Actually, I finished and loaded the game in the morning, and I'm happy it's launched. But I have to go to work, so I can't share thoughts. I just seen the start screen. Um, I totally believe that visually it's completely neat and technically it's perfect. I can't judge by splash screen, but I love games like Deus Ex Human Revolution and Watch Dogs, and I guess Cyberpunk will be something like that or even better.
Um, yes, CD Projekt and Cyberpunk is actually a very good example of the differences between Western, like American style and the European style, because Cyberpunk is oriented with all these features, with all this storyline oriented on single player, and with all this very long time of development, it's just very niche product. But still, it's as a niche product, it's overwhelmingly popular in America and like in that part of the world. I would say that not that much companies would invest into such a very long term and niche products. Usually, another clone of Apex or Fortnite is quite fast and makes a good return on investment in a short period of time. So that's a good behind the European game scene, because they are really into producing such games as Cyberpunk.
Great. Good to have it finally. So we hope that you guys have a good experience playing it. And now for the next question, question number 4. There are some questions left. So, have you noticed any challenges or obstacles, maybe worth mentioning, about molecular MR multiplayer? Anything challenging? Anything especially difficult?
Actually, everything challenging. Actually, we got guys from scientific teams. We are more closer to interaction, but they are trying to push frontiers of actual science beyond the limits, so they can bring any kind of challenges day by day. So if you manage to put those molecules properly, squeeze it down to the small device, make it absolutely natural to interact, they can provide you larger moleculars. They can invent anything like that. So we have still questions that working like what was mentioned in Firefox on PC. On that, NVIDIA is working with millions of molecules with GPU or supercomputers. Uh, but when we having to put it on the edge, to put it to the glasses or pockets of scientists, we have lots to tasks to be creative, tasks to be technically cool. So, uh, like uh, month by month, we were facing new challenges and still have several in the bucket that we can come back or share with somebody. We are open to collaborations and have a lot of challenges.
Okay, question number 5. What was the most memorable reaction to molecular MR multiplayer?
The most memorable reaction was for me at poster session at VRST when third or fourth part of people came, and they looked at that and asked me, okay, it's cool, it's nice, please tell me in several words what are you doing there. And when I managed to say that we are helping scientists to gamify their work, it was all cool. Why you were reading so much of papers and so on? It's clear in 5 words.
Yes, I hope this answers your question and prepares those interested for future questions like that and reactions like that. And now about the future. Would you guys want to share your thoughts on what you think is the future of game dev, short term but also long term speaking? How do you see the future of game dev?
I see the future is bright. I always liked the games. I always will do, and I see this moment as exciting because new level of tech coming, new wave of consoles, new wave of hardware. In so short term, in longer term, I believe uh, Unreal Engine 5 with point clouds can transform graphical pipeline dramatically. And if we look in long term and we are looking in something futuristic, so we not only believe but dig in the direction that we're going to have digital overlay or digital overlays or digital clones of the world, and that it's going to be completely playable all over. So yesterday at the Graph Asia 2020, the girl from Australia has presented the concept of playable cartography. So you can play over the real world, like coming and finding your way to the next bookstore, let's say, in gaming way. And even further, things like brain computer interfaces are long known but totally accelerated by guys like Elon Musk. So I believe we are going to play in lots of new different ways. So let's say like Microsoft promotes their Xbox, uh, people has a natural gift for playing. Don't lose it. Work less, play more.
Yeah, from my side, I can totally be sure that there is a future and game dev is forever because the generations are changing, switching, and the older generations that had no information about computer games and was like prohibited mostly people from gaming, is replaced by the yes generation that just get used to gaming, and the gaming is it is forever now with us. The good question is what are the short, long term? The short term, it's important to understand that the gaming as it develops, it would be platformized. So the game on mobiles is very different story from the gaming on consoles and the gaming on PCs. And we can understand that the gaming, again, gaming for just mentioned Fortnite and Apex is very different in the behaviors as gaming for Cyberpunk and single. So we can be sure that the gaming would be split in different categories. Same as movies now, same as media content. And in long term, it would not be the question of the gaming, but it would be the question of the type of gaming you prefer. Like now, do you prefer online? Do you prefer co-op? Do you prefer single? Do you prefer indie? And as same as movies, there would be a very wide selection in each categories. There would be a popularity of genres that would be go up and down. So if you want to see a long-term speaking prognosis, just look on the movie industry now. The gaming industry is going the same way as the movie industry from like arrival of Train and Lumiere Brothers to the latest Avengers movies. The game industry is going the same way in the long term. And let's not forget that with IR glasses, that would be in 3 or 4 hours, a new type of games would arise. I cannot like imagine what it would be. Maybe something geospatial and like Pokemon Go, or maybe something else, but it would be a new niche for game development. So we are watching it very closely, what the experiments there and the experiments and the I would say latest results shows that a very new type of gaming experience would arise after this technology would be adopted by mass market. So new things to come, I would say. Watch closely, very new things to come.
But the end isn't anywhere near, as you said, right?
There is no end.
There is no end. Oh, actually, there
No.
is no end. Okay, and now some greetings from your neighbors from here from Poland, and a question: do you guys think the game dev community in Ukraine is more of a competition, or are the people collaborating and supporting each other?
I bet that supporting each other. I'm reading several channels like Game Developers in Ukraine, and I see tons of mm, asks for ask for collaboration and responses for there, and I see a lot of requests for feedback and literally hundreds of comments with feedback and literally constructive feedback, not some kind of empty stuff. So for me, Ukrainian game dev community is open and collaborative, and I hope it's going to grow further and like going to com- maybe compete or maybe collaborate with community
Um,
I
Sam,
think we
have we
are,
lost?
yeah, I think we are losing
Okay.
Sam. Let's just wait another
Okay.
moment, but I think we have a problem with his
I, I
connection. So maybe
I will
Oleg, you
go on.
can
Yeah.
you can go on, yeah.
Mhm. So from my point of view, obviously collaboration is support is important, and it's more collaboration than competition because not that big industry in Ukraine game dev. Like it's okay, but not overwhelmingly big. And as a small industry, we always try to support each other.
That's great. And during your answers, Wojciech wrote greetings from 4A Games Malta. So guys, you're
Yeah.
greeted by Malta,
Hi.
and also we are happy to see that somewhere along the way Roxana came here, and also I think Daria somewhere. I can't see the account. Yeah, Daria, good evening on behalf of SoftServe. Really happy to be here. We are happy to have you, and also greetings, Daria. Thank you for your support. But there is also another. There is one more question that I would like
Mhm.
to show you. This is the one about testing the Unity plugins so that they meet our viewers' expectations or requirements.
About testing Unity plugins, it's good to understand what testing we are talking about because if this question how you can buy something from Unity store, test it out, and return back if it's not working, then there is a money back mechanism for Unity store, and you can buy something and then return with explanation why it was not working. As usual, as in any kind of platform shop or any physical store, you can just buy and then write that you are not satisfied, and use there is a money back guarantee. As of if I talk about testing Unity plugins inside Unity, like testing purposes. So it's usual just install and try and write some tests and verify everything. But I don't think you was asking about the second one. I suppose this first part, that's money back guarantee. It's written in the Unity store and you can easily find the information there. I don't remember correctly because from my experience, I was verifying quite thoroughly the packages that we were buying, so I had no issues.
And that's great. So this was the last question that we got from our viewers. So Oleg, thank you so much for giving us your time and your knowledge and your expertise. Thanks so much for sharing it. We appreciate it very much, and we hope to see you again online or maybe one day in person during one of our events.
Okay, thank you a lot for your invitation. I was very happy to be part of the community, and I hope you liked the project I was working on. And I would be very happy to be in person when all this hustle with closed borders and all this stuff just goes away. I would be really happy to join you physically.
We really hope it will go away one day, and I hope
Yes.
it's even nearer than further. Thank you so much, guys, for joining us today. Once again, huge thanks to SoftServe for being our sponsor and working with us to develop the whole community. We promise to host another events like this. If you also want to join us next time, be sure to check out our social media, mostly Facebook. We will let you know. And I think Sam is joining us for those last seconds of our event. We are adding him to stream. SoftServe for being our sponsor and working with us to yeah, but I'm hearing myself, but I'm seeing Sam,
Yeah.
so I think it's I think we are here together. Join us
Uh,
next time.
uh, uh,
Be sure to check
uh,
out our
yeah, it's a
social
delay, I
media.
suppose.
It's a delay, yeah. But still, I think one moment Sam will hear us.
Uh,
Sorry, something crashed. Yes.
Okay.
yeah.
Yes, I'm
Now
here.
you can
Sorry,
hear us.
something. Yes, yes, I hear you. I can see you. Thank you for inviting me. Something crashed on my side, so sorry for technical
Okay.
issues.
But we are very glad once again that you guys joined us and shared your knowledge, shared your experience. If our viewers have any more questions, please join us on our Facebook. Please give us information if you need any sort of clarifying, and we will also inform you guys when we have the next date of our next event. So thank you again to our speakers, to our sponsor, and to you guys, and we'll see you again very soon. Bye bye.
Okay,
Thank
bye.
you. Bye bye.